given this, the active forces I can list. Force mg acting downward at P, mg acting downward at Q, Ay acting upward at A. These are the active forces, I have just listed them. Okay. I can now write the appropriate virtual displacement so that it is easy to do the calculations. Let me erase it and write it nicely. I will identify the points where the active forces are existing. This is point, this is the force with the appropriate direction. I am going to write the virtual displacement. Then I will do an F dot delta disp. Okay. Remember, I am just going to do a multiplication here if I take the appropriate directions. Okay. At P it is mg downward, alright. This can be written as minus mg because upward is taken as positive. Again here minus mg. Okay. Just to give you an idea, the directions are like this. How about at A? It is Ay upward, right. Displacements, we gave a displacement of positive direction here, delta A y, I am sorry, delta y A. Right. What did we get for these two? This is a positive quantity, upward is what we have given. This at Q we got it to be plus delta Ya by 4 in the positive direction. This is delta 3 by 4 delta Ya in the positive direction. Okay. So what do we finally get? If we multiply these two, we get minus 3 by 4 mg delta Ya minus 1 by 4 mg delta Ya. This one is Ay times delta Ya. Okay. Delta Ya is common in all of them. So we can immediately write from virtual work principle Ay minus 3 by 4 mg minus 1 by 4 mg times delta Ya equals 0. Delta Ya is an arbitrarily applied virtual displacement, which means that this has to be equal to 0, means Ay equals mg. Well, that seems to be obvious here. I have weights of these, nicely symmetric one, the reaction, vertical reaction here and vertical reaction here should be half and half of the total weight. Total weight is mg plus mg. So automatically Ay will be mg, By will also be, Cy will also be mg. Okay. So that verifies that I have done correctly. Okay. The advantage of this is you do not have to do the entire equilibrium for this system, but then you have to sacrifice on finding out kinematically admissible displacements, kinematically admissible displacement, and this is crucial. Okay. And mind you, the signs of signs is very important to get the appropriate equations, right. Thank you. Supposing we had started with this, let us say the direction is like this and Ay, and we had applied a virtual displacement in the upward direction. Now this would be downward like this and therefore a negative value, and this would have become negative, right. What would happen here? I would have a negative sign here, which means this is Ay equals minus mg, or in other words Ay is acting upward with the magnitude mg, consistent. The equation of equilibrium is consistent to what you get, right. So never mind what displacement, virtual displacement you give, you will get finally this particular equilibrium equation. As an exercise, I want you to apply a virtual displacement at B and do the problem, okay. Another way of doing it is apply a virtual displacement, virtual rotation between AB and BC, okay, and write down all the displacements with respect to each of them, the either the rotation or the displacement at B, okay, and verify that you get exactly the same equation, alright. You have to get same equation, the reason being you are using kinematically admissible virtual displacements, okay. They will always be proportional. If you take delta Ya here or some other quantity, they will proportionately be different, okay. This relationship cannot change. Thank you.